Dear students, in this video we are going to see a problem in sets, relations and functions. Okay? In our textbook, exercise 1.3, problem number 10. If f and g are two functions defined from R to R, defined by f of x equal to modulus of x plus x and g of x equal to modulus of x minus x, then find J composite f and f composite g. Okay? J composite f means the composition of f with g. Okay? The composition of f with g is denoted by G composite f. Similarly, the composition of g with f is denoted by f composite g. Okay. Do you know about modulus function? The modulus function is defined as for x is greater than or equal to 0, it is simply x. Whenever x is negative, that is whenever x is less than 0, the value of modulus of x is equal to minus x. Okay. Now, by the definition, modulus of x is equal to x if x is non-negative, that is x is positive, also x is equal to 0, and minus x if x is negative. So, this is the definition of modulus function. When x is non-negative, the value of modulus x is as it is x. Whenever x is negative, the modulus of x is minus x. Okay. Now, let us redefine the function f of x as well as g of x. First, let us redefine the function f of x. Okay. Given that f of x equal to modulus of x plus x. So, f of x equal to, instead of modulus of x, we have to write x when x is non-negative. So, x plus this x is as it is. So, x plus x if x is non-negative, and whenever x is negative, the value of modulus x is minus x. So, minus x plus x if x is greater than, sorry, if x is less than 0, if x is less than 0, that is f of x equal to x plus x is 2x if x is non-negative, and minus x plus x becomes 0 if x is negative, right. Now, let us redefine g of x. What is g of x? G of x is equal to, when x is non-negative, modulus of x is simply x. So, this is x minus x if x is non-negative, that is whenever x is greater than or equal to 0, the value of mod x is simply x. Again, if x is less than 0, then modulus of x is minus x. So, minus x if x is less than 0. So, g of x is equal to x minus x becomes 0 if x is greater than or equal to 0, and minus x is nothing but minus 2x if x is less than 0. Now, we have redefined the functions f and g. So, f of x is, here f of x is 2x when x is non-negative, f of x is 0 when x is negative. Similarly, g of x is 0 if x is non-negative, and g of x is minus 2x if x is negative. Now, let us find J composite f. Now, let us find J composite f. Okay. Here, we have to consider two cases when x is non-negative and x is negative. Case 1, x is non-negative, that is x is greater than or equal to 0. First, let us find G composite f. Take any arbitrary element x. So, G composite f of x. By the definition of composition, this G composite f of x can be written as G of f of x. This is actually the composition of f with g, it is denoted by g composite f. Okay. So, g composite f of x is equal to g of f of x. This is equal to g of, what is f of x? When x is non-negative, that is when x is greater than or equal to 0, what is f of x? 2x. When x is greater than or equal to 0, the value of f of x is 2x. So, g of 2x. Okay. Now, x is non-negative. So, 2 into x, that is 2x is also a non-negative number. When x is positive number, if you say x is 6, then 2x becomes 12, that is positive. If we take x equal to 0, then 2x is 0. So, anyhow, whenever x is greater than or equal to 0, this 2x is also greater than or equal to 0. So, this quantity is a non-negative quantity, that 2x is a non-negative real number. Okay. Now, when x is non-negative, what is the value of g of x? It is always 0. G of x is 0 for all non-negative numbers. G of x is 0 for all non-negative numbers. Whenever x is greater than or equal to 0, the value of g of x is simply 0. Here 2x is a non-negative number. 2x is a non-negative number. So, g of 2x is 0. Right. Since x is any arbitrary number, that is g composite f of x equal to 0 for all x greater than or equal to 0. Now, case 2, when x is less than 0. Now, let us find the value of g composite f. Take any arbitrary element x. This is equal to, by the definition of g composite f, it becomes g of f of x, g of f of x. This is equal to g of, here x is negative. So, whenever x is negative, what is the value of f of x? Let us see the function f of x. When x is negative, the value of f of x is nothing but 0. So, in the place of f of x, we have to put 0. Again, what is the value of g of 0? G of 0, here we have to use this value, because whenever x is greater than or equal to 0, g of x is simply 0. So, in this case, if you substitute this 0 also here, g of 0 is also 0. G of 0 is also 0. So, by using this definition, this g of 0 becomes 0. Therefore, g composite f of x is equal to 0 for all x less than 0. Now, combining these two, that is, for all x greater than or equal to 0, the value of g composite f of x equal to 0. Similarly, for all values of x less than 0, g composite f of x is equal to 0. Hence, g composite f of x equal to 0. This is true for all x belongs to R. Here, this R stands for the set of all real numbers. Okay. Now, g composite f of x equal to 0. This is true for all x belongs to R. It means the function is identically 0. It means the function is identically 0. That means it is a 0 function. Therefore, g composite f equal to the 0 function. Now, let us find the value of f composite g. Okay. Here also we have to consider two cases. Case 1, x is greater than or equal to 0. F composite g of x. F composite g of x. That is, by the definition, f composite g of x is equal to f of g of x. This is equal to f of. Now, what is the value of g of x? What is the value of g of x? when x is non-negative. So, we have to see g of x when x is non-negative, that is when x is greater than or equal to 0, the value of g of x is 0. When x is greater than or equal to 0, the value of g of x is 0. So, in the place of g of x, we got to substitute 0. Now, what is the value of f of 0? What is the value of f of 0? Here, f of 0 means the value of f of x at x equal to 0. So, in the place f of x is equal to 2x if x is greater than or equal to 0. Here x is 0. Therefore, f of x is 2x, that is 2 into 0, it becomes 0. When x is greater than or equal to 0, the function is 2x. Whenever x is non-negative, f of x is 2x. That is 2x, in the place of x, we have 0 here. So, 2 into 0 is nothing but 0. Therefore, f composite g of x equal to 0. This is true for all x greater than or equal to 0. Now, case 2. Case 2 is when x is less than 0. Now, f composite g of x is equal to, by the definition of composition, this is nothing but f of g of x. When x is negative, what is the value of g of x? Okay. So, when x is negative, what is the value of g of x? It is minus 2x. It is minus 2x. So, g of x is nothing but minus 2x. This is equal to. Now, you have to listen very carefully. Here x is negative, but minus 2x is positive. Since x is negative, let us say any number, any negative number x. For example, if you take x as minus 5, then minus 2x becomes minus 2 into minus 5, that is 10. Okay. It is a positive number. So, whenever x is negative, this minus 2x is a positive number. So, inside this bracket is a positive quantity, that is minus 2x is a positive quantity. So, f of this value, now we have to find f of a positive quantity. So, we have to use this function, because when x is negative, then only we have to use f of x equal to 0. When x is 0 or positive, we have to use this function. When x is positive or non-negative. When x is positive, f of x is 2x. Here minus 2x is a positive quantity. Therefore, we have to use this definition. So, f of x equal to 2x. Here 2 into, in the place of x, we have minus 2x. This is equal to 2 into minus 2x, that becomes minus 4x. Therefore, f composite g of x is equal to minus 4x. This is true for all x less than 0. So, here J composite f is the 0 function, but here f composite g of x equal to 0 for all non-negative numbers, but f composite g of x is equal to minus 4x when x is a negative number. Okay. This ends the problem. Okay. Could you understand?